Let's see how to implement the priority based interrupt driven IO using the parallel method. So in serial method we have seen that all the IO devices are actually connected to the same line, and then depending on their placement we are able to give the priority to each device. Here also we will assume that there are 4 devices. One is disk, other is printer, other is reader and keyboard. So here, instead of having the same line, each device is allowed to raise the interrupt, and then that interrupt will be allowed to pass through parallel channels, right? So if you observe this one, we are having a dedicated resistor. In this resistor, each bit is dedicated to one IO device. If a disk wants to send a interrupt, then it will set this particular 0 bit as 1. If printer wants to send an interrupt, it will set 1 as, this particular bit as 1. Reader, this bit as 1. Keyboard, this bit as 1. As you can see here, what we'll try to do is, we'll implement this system in such a way that disk will be given highest priority, and the priority will keep on decreasing, and keyboard will be given the least priority. That is how we are going to build this, okay? And then so this resistor is dedicated to fill the bits as and when the interrupt is generated, and these interrupts are given to the decoder, priority decoder, through AND gates. Now these AND gates are used for masking, and for that masking we have one more register, which is mask register. So if you want to understand what we are trying to do here, think about it this way. Assume that disk is having the interrupt now, which means this particular bit is 1 and all these bits are zeros, okay? Now what will happen is, when initially this one will always be 1, okay? So this one will always be 1, and now whenever this one is 1, whenever we start processing, later at some point, if any of these devices they raise the interrupt, we don't want to stop processing this particular ISR, which means when the interrupt which is raised by a higher priority device is getting processed, we don't want other devices to create an interrupt. That is the reason whenever we are processing the interrupt which is given by disk, we generally put all these bits as zeros. So even when any of these devices they raise an interrupt, they will be masked out here in the AND gate. So since these 3 bits are zeros, even if we get a 1 here, any one of these places, right? So output of these gates will always be 0. So that is how this mask register is used. So the main purpose of using this mask register here is to block out lower priority devices from interrupting whenever a higher priority device is actually getting serviced, right? And one more thing, you need not by heart this, I am just explaining you for the sake of understanding. So in case if they give you such a circuit in the exam, you will be able to analyze it. So that is the reason I am giving you this. So you need not by heart this, try to understand it and leave it. Maybe you can take it down and revise it, but then you need not by heart it, okay? Now you understood these two. So this register is used in order to store the interrupts which are raised by these devices initially there, and this one is used for masking appropriately. For example, if the interrupt is raised by printer, and now currently the ISR is running which is corresponding to the printer particular thing, then this one has to be 1, because whenever we get disk, an interrupt by disk, even if you are servicing the printer, you should stop that service and go to the disk and service it. That is why this one will be 1 and these two parts will be zeros. Why? Because printer is higher priority, and these 2 bits which correspond to reader and keyboard, they should not interrupt the printer when printer is getting serviced. That is the reason. Got it? Okay. Now see this. So anyway, whenever there is an interrupt, that interrupt will travel through the gates and get on to this priority encoder. Now assume that initially all the mask bits will be 1. So initially nothing will be 0. Initially all of them will be 1s. Okay. nothing will be masked out. So masking process will happen when you start servicing an interrupt. So that will be the first step. Changing the mask register will be first step in the interrupt service routine. As of now, all will be 1. So assume that all the devices have also raised the signal 1, which means disk has raised the interrupt, printer, reader, keyboard, everything has raised the interrupt. Now what happens? All of these will be 1s, right? Now what will be the output of this priority encoder? So priority encoder, if you remember this, you please go back to digital and watch the video about priority encoders. There we have discussed about it. Priority encoder works this way. See this. Now we have 4 inputs: I0, I1, I2, I3, and the outputs are 2. Let me call it X and Y. Okay. So now if all of these are having 1s, which means if all of them generate the interrupt, then the output should be 0, 0. That is how it is implemented, which means highest priority will be always given to 0. In case if this is, how to implement this one is, if there is an interrupt which is generated by disk, which means this particular bit is 1, I don't care about the remaining devices. Yes, we have to put don't cares here. I don't care whether the remaining devices have interrupts or they need the interrupt service or they don't need. I don't care about it. If disk requires an interrupt, always 0 will be the output, which means disk has to be serviced. In case if disk says that I don't need any service, then if this one is 1 and if these two are don't cares, so which means in case if printer needs an interrupt service and if this disk doesn't need any interrupt service, then irrespective of what the remaining 2 devices say, we should always go and process the interrupt service routine of 1, which means output will indicate that you have to service the device 1. In this case, device 1 is nothing but printer, device 0 is disk, right? In case if disk doesn't need this service, printer doesn't need this service, if reader needs this service, then irrespective of what keyboard wants, right, we are always supposed to process the reader, because reader priority is high. That is how we want to implement it. Okay. And why do you think that these priorities are given in that order? That is depending on the speed of the devices. In case if none of these devices, first 3 devices, if none of them wants interrupt, then if I3 wants the service, yes, then only I3 will be granted this service. Got it? So now if you can observe this, now all of them want this service, but then who will get the eligibility? Disk will get the eligibility. Therefore the output will be 0, 0, right? So this particular thing, it is nothing but the vector address. So I told you that this particular parallel connection will also fall under the category of vectored interrupts, which means the device which is interrupting, in this case the disk, is supposed to provide you with the address of the interrupt service routine as well. So all these bits put together is going to form the address of the interrupt service routine. Got it? And this address will be sent to the our CPU. So which means at the address all zeros in the memory, at the address all zeros, we have the ISR, interrupt service routine, which will service the interrupt raised by the device disk. Got it? So in case, assume that the device which we get there is printer, then what do we get here? 0, 1, right? So 0, 1 followed by all zeros, so which means somewhere here there will be ISR which will be servicing the printer, right? So its address should start with whatever you get there, which means 0, 1 followed by all zeros, right? Similarly, somewhere where the ISR of this interrupt service routine of reader is present, you will have 1, 0 followed by all zeros, right? Similarly, you'll have somewhere ISR which is 1, 1 followed by all zeros. That is how the device which is causing the interrupt is also supposed to send the address to the CPU. Got it? Okay. Now along with that, priority encoder is also giving you one more output which will say whether one of the devices or whether one of the inputs here is 1. Got it? Which means it will say that there is some input. So for that reason we are going to use a special flag which is called as IST. So IST means there is at least one particular interrupt which is active. Got it? One of the device needs the service. In case if all of these are zeros, this particular thing will be 0, right? So this particular bit indicates that at least one of the device has raised the interrupt. And IEN flag, you know this, we want to be interrupted or not. Sometimes we don't need any interrupt to work, we don't want to service any device, then we can set IEN as 0, right? In case if you are working in, let us say if you are executing a code in the operating system and we don't want to be interrupted in between, then we can set this one as 0. Got it? So if this one is 1 and if this one is 1, what does it mean? It means that at least one of the device has raised the interrupt, and our CPU has already said that, or of the program which is running has already said that I want to be interrupted in case if there is some interrupt, then say this. So in that case, if you observe this AND gate, one of the input is this one and the other input is this one, right? Okay, this one, let's talk about this AND gate. One of the input is this one and other input is this, which means there is an interrupt and our program has already decided that I want to be interrupted. Then in that case interrupt will be generated. So first of all, what happens is they will be, all the devices have requested for some interrupt service, and then all of them have shown their interest here, right? And now first this one will happen, which means it will show that someone wants the interrupt service routine, and this will show that the programmer is willing to be interrupted. If these two things both are saying yes, there is an interrupt, and yes, there is a program which is willing to be interrupted, in that case only an interrupt will be sent to CPU. As a response, CPU will send the acknowledgement, right? See, now when the CPU has sent the acknowledgement, that acknowledgement will be given to this gate. Now this particular gate is also having the input as there is some interrupt, and as CPU wants to be interrupted, which means this particular gate will get 1 only when there is an interrupt and when CPU wants to be interrupted, and CPU is ready to process the interrupt. In that case this one will be 1. Now whenever this one is 1, this particular register will be enabled. What is this register? This register contains the address of the interrupt service routine. Now this particular address will be given to the CPU. Now CPU will go to that particular interrupt service routine and start executing it. The first step of that interrupt service routine will be to set the mask appropriately. If the interrupt that is currently being serviced, if the interrupt service routine is servicing disk, then it will try to make this one as 0, this one as 0, and this one as 0. So what happens is, till that particular interrupt is serviced, whatever happens to these bits, always these bits will be zeros, which means no one can actually interrupt. A lower priority device can never interrupt a higher priority device when it is getting serviced, right? Then after the interrupt service routine is over, in the last step it will again enable everything like this, 1 1 1. Got it? So assume that disk doesn't need this service and these three devices need this service. Then what happens here? Disk will get 0 and these three will get 1, right? And now according to the priority encoder here, so disk doesn't need it and the printer needs it, and these two we don't care. Then what will be the output? Output will be 1 0 0 1, right? Which means here you get 0 and here you get 1, right? So that means the one which will be processed will be the printer. Got it? Now when we go to the printer's interrupt service routine, that particular interrupt service routine will try to disable these two, but then it will enable this one, which means when the printer is getting serviced, this particular interrupt is getting serviced, it is allowing this disk to interrupt it. Got it? So while during its execution, in case if this one turns to be 1, then automatically we'll stop the work which is being done, or we'll stop that ISR of printer and we'll start with the disk. Are you getting this? So I hope that you are getting everything here, right? It is very simple. I don't know whether you are getting it or not. I hope that you are understanding it. See, in simple words, whenever there is an interrupt, whenever all of them are sending some interrupts, this priority encoder will choose which one will get the ISR address there. Depending on the ISR address, that particular device will be selected and it will be processed, right? And then we will be setting this mask depending on which device is getting serviced. We'll set this mask in such a way that a lower priority device will never be disturbing the higher priority device. Got it? And these particular flags, they are just kept here in order to decide whether to send an interrupt to CPU or not. If we have initially decided that IEN is 0, I hope you remember that there are some instructions using which we can set IEN, interrupt on and interrupt off, right? So if interrupt is on, which means the program has already decided that I want to be interrupted if there is some activity, right? So if the programmer wants to be interrupted, and in case if there is an interrupt, so this particular flag denotes that someone here wants a service. If any of these bits are 1, this one will be 1. That is how it will be programmed. It is simply an OR gate. It will take all these inputs and it will put a OR gate, right? It is saying that there is some input, that if there is some interrupt, it is saying that yes, I want to be interrupted. In that case only an interrupt signal will be sent to CPU, and CPU must be, whenever the interrupt signal is raised, CPU must be doing something in the instruction cycle. So till the instruction cycle is over, will not do anything, right? Nothing will happen. So once the instruction cycle is over, then again when T0 starts, then only CPU will check whether there is an interrupt or not. In case if there is an interrupt, instead of taking up the instruction cycle, it will take up the interrupt cycle. Now as a result of that interrupt cycle taking up, it is going to generate this acknowledgement. Now this acknowledgement signal will come here, which will enable this particular address, and now this address will be sent to the CPU, and CPU will load the program counter with this particular address, and automatically the interrupt service routine will start executing. And what will that program do? It will try to set this mask in such a way that a lower priority device will never interrupt a higher priority device, and a higher priority device should be able to interrupt a lower priority device. Got it? Okay, so this is how we are going to implement it in hardware. It doesn't mean that we don't have any software involved. Finally, interrupt service routine is a software, but then the way we decide which of the devices wants the service and the address where the interrupt service routine is, that is all done using the hardware, and so it is faster compared to software method. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days. And whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.